Hi, welcome back to the Cuzzy Sound channel, and let me introduce you to my latest little box. Here it is. It's the 40106 VCO. But this isn't just any ordinary VCO. This little box VCO has one or two features which I'm sure will help make it a really valued member of the Little Boxes Orchestra. So what I'm going to do is we'll start by looking at how I laid the circuit out on the breadboard to get the concept going for what I wanted with this. Then we'll have a look at how I developed that into a circuit diagram, and then the stripboard layouts that are inside this little box. And to finish off with, we'll wire it up, probably link it up with Project 12 just to give it a real good workout, and we can have a listen to some of the things that this little box is capable of. This is the breadboard circuit. So you've got the 4106 chip in the middle there, and I've got it set up with just one oscillator. So the classic arrangement of a potentiometer between the input and the output of one of the inverters, and then there's a capacitor going between the input and ground. Now what I've done, the values for the capacitor and the potentiometer I've chosen such that I've got a fairly low range of frequencies to play around with, because I wanted a VCO that kind of could be used as a bit of a bass synth, I suppose, really. This device here, this is a homemade Vactro, and what I've done, I've wired that such that the resistor side of it is across the input and output, so it's kind of in parallel with the potentiometer, and then I've got an input that goes into the diode side of my Vactro. There's also inside the heat shrink there, there's a resistor, a current limiting resistor. But what I've done on the input for the CV control for the Vactro, I've got this potentiometer here. So this basically, it's a voltage divider, so it sets the CV level going into the Vactro, and then this is the output. No, this is the output. That's what's going to the Vactro via this. That's the output, which I've got going into a small amplifier at the moment. I'll put some power to the circuit. I'll turn the power on to my little amplifier, and then put some power to the circuit. Almost down to LFO type levels there. So the value for the capacitor is 1 microfarad, and the value for the potentiometer is 100k. What I'm using on the potential divider here, that's a 50k. What I'll do, I'll pull the camera back so you can see a little bit more of what the boxes are around here, and then we can have a listen to it playing a sequence from Baby 8. Okay, this is the breadboard that I've just been describing. This is a Little Boxes Baby 8 sequencer. This is it's just an amplifier. Yeah, it's got a little I think it's 3-watt circuit that's in this, but what it allows me to do, turn the power on to the amplifier. So once again now we can hear the oscillator. What I've got coming out of baby 8 going into the socket here via this potentiometer here. So if I turn it such that I've got maximum CV, okay, it's not going to win me a Grammy award, but you know. But what I can do, I can control the voltage, the CV level. And what you should hear as I do that, also changes the pitch. Which makes sense because the voltage going into the diode will dim the diode, which will cause a change in the resistance on the LDR that's the other end of the Vactral. So there's a light dependent resistor there and there's the diode there. But what it does mean now is that so what I can do now, I can get a kind of a little bit more control over the CV that's going. So that was kind of testing the concept. So we'll go and turn that off. We'll go and have a look at the circuit diagram. What I've done for the circuit as well is I've actually, because we're only using one of 6 inverters here, so what I've done, I've used another one of the inverters and I've wired that one up as an LFO, a low frequency oscillator. So I've used another 100k, but I've used a 10 microfarad electrolytic capacitor. But you'll see that on the circuit diagram. And you'll see that that then allows me to switch in CV control and LFO input via the Vactral. I'm getting ahead of myself a little bit here. We need to have a look at the circuit diagram. So we'll have a look at that. Then we'll look at how I put it all onto strip boards and built it into the Little Boxes box. This is the full finished circuit diagram with everything added, and I'll come to all the additions in a moment, but let's start with what was on the breadboard. So the first thing that we had there was the square wave oscillator, and these 3 components here are what make the square wave oscillator. As simple as that. We have one of the 4106 inverters, we have the 100k potentiometer, and we have the 1 microfarad capacitor. So the potentiometer is connected between the input and output of the inverter, and the capacitor is connected between the input and earth. And then at this point here we will get a square wave signal out, the frequency set by tweaking this potentiometer. Very simple arrangement. The other thing that was on the breadboard was the Vactral CV arrangement. So this represents my DIY Vactral. So you've got a light dependent resistor, a diode, and then if you remember I said there was couldn't see, but there was a resistor inside the heat shrink. Well, there's a resistor. That's just current limiting resistors so you don't burn out the diode. And then ignore this bit for the time being. We've got the CV input jack, and then we have our potential divider, the 50k pot, where the signal, you've got the signal at one end and earth at the other end, and then you take the divided CV out from the center tap. I'll explain this in a moment, but that signal then drives the LED, which drives the Vactrol, which alters the resistance, which is now in parallel with the potentiometer across the inverter. There you go. Let's have a look at the next thing that I added, which is this bit at the bottom here. So it's another oscillator. So we have our three components again: the inverter, the 40106 inverter, the 100k potentiometer, but now we have a 10 microfarad capacitor on between the input on the inverter and earth. What this does is it creates a low frequency oscillator, an LFO. So the bigger capacitor generates lower frequencies. One thing to note is for this one I used a non-polarized capacitor. When I came to the 10 microfarad, I used an electrolytic capacitor which is polarized, so you're going to make sure that the positive side goes to the input of the inverter and the negative side goes to earth. On the output from this square wave oscillator, I've got an LED and a resistor. Again, the resistor is just there to protect the LED. But what this does, it gives me a visual representation of the rate that I've set on the LFO, and then we have an output here. We also have a spur coming off here which goes up to this switch arrangement. Now this is a double pole, double throw switch. So with the switch in this position, it's connected to the divided CV signal and, well, nothing at this point. So you're just getting the divided CV signal driving the Vactrol. If we flick the switch, then they both move down. So we still have the divided CV signal, but we now also connect via this 1K resistor to the output from the LFO. So the Vactrol is now being driven by both the signal coming in at the CV and the signal coming out of the LFO. So if you plug nothing into the CV, you just get the LFO. If you plug something into CV, you get CV and LFO. And that's the reason I've got that 1K there, because I found that without that resistor in, I was getting some weird interference going on between the signals, and it didn't really work too well. Put that 1K resistor in, and you could clearly hear both signals. So I could now modulate my square wave oscillator with both an external CV and the internal LFO. But I've got an output socket on the LFO as well, so I can always take the LFO signal out somewhere else. And then finally, the other addition, if you take the signal from the input side of our first inverter, you actually at that point get a triangle wave output. So on the output you've got the square wave, from this end you get a triangle wave, but it's a very low amplitude, so you need to boost the signal. So we're using another inverter, a 4069 inverter. What happens here is on this first arrangement we've got matched resistors, so we've got basically a unity gain buffer. On the second arrangement we replaced one of the fixed resistors with a potentiometer. So by adjusting the potentiometer we can now adjust the gain of this particular buffer and therefore adjust the level of the output of the triangle wave. Now, because the triangle wave is generated from the same signals as this, whatever effect you've got from the LFO and the CV will also affect the triangle wave. So that will have CV control as well, because it's all coming from the same oscillator. So there's quite a lot going on from what is essentially a relatively simple circuit with not a massive amount of components in there. So what does it look like when we put it on Stripboard? Well, this is the complete arrangement, which looks a little bit scary, but that's because we've got lots of external components wired to it. So we've got the Vactrol arrangement and the switch here with the LFO arrangement here. Then we've got our square wave triangle wave at the top. What wasn't on the schematic is the power supply. So it's a 9-volt battery clip going with the positive side going through a simple switch to the circuit board, but also on the switched side we have another current limiting resistor and an LED, such that when the battery power is on, the LED is lit, so I can see that I've left the battery switched on, and so if I'm not using it, I'm actually just running it flat for no reason. So that's useful to see. This is not easy to see, so let's have a look at the board in a little bit more detail. So there you go, the 4106, the 4069, that's your 10 microfarad generating your LFO along with the pot down here, the 1 microfarad for the square wave along with the pot here, and then the 100k resistors with a pot that's off the screen is the gain for the triangle wave. So what's with all the black lines down here? Well, it's good practice to ground all the non-used inputs on your inverters. So that's what all these black lines are. It's earthing or grounding of the unused inverters. It's just good practice and helps prevent interference on the ones that we do actually want to listen to. Okay, so if we put it in a box, the way I've laid the box out is like this. There's our square wave with the frequency control and the output. That's the gain control for the triangle wave output. That's the rate control for the LFO output and the LFO indicator LED. There we have the CV input and the potential divider to set the CV level, power switch and indicator, battery indicator LED, and then this is our double pole double throw switch, which switches between CV and CV plus LFO. And then inside the box it looks like this. So yes, the scary layout diagram looks just as scary when it's inside the box, but it's just a case of systematically working your way through connecting all the wires into the right places following the diagrams. Incidentally, the diagrams will be on my Dropbox folder, and I'll put a link to that in the description to this video. One other thing to note is, for this arrangement, the Vactrol I've used here, I've put it on its own bit of stripboard, and the resistor isn't inside the heat shrink, it's actually on the end of the board here. But other than that, it's the same kind of arrangement with an LED and a light dependent resistor, and then it's just connected via back to the switch and the main circuit board. And that's it really. These are just some of the current limiting resistors that I was talking about earlier on. So yeah, it's just a case of patiently wiring everything together following the diagrams. Well, that's the circuit, that's the stripboard layouts, that's it all in a box. But what does it sound like? Let's go and have a listen. The setup I've got here is the 4106, which we now know has got a few more tricks up its sleeve. So we've got the square wave VCO, triangle wave with a gain control, the LFO, we've got a CV level control, that's the main power switch, got CV input. In the up position, this switch is just reading the CV. If I flick it down, it will read both the CV and the LFO. That's if CV is plugged in, if not it's just reading the LFO. Because it was the switch I had available, this switch also has a center off position, but that's just because that's what I had. It really should just be a double pole double throw to achieve the effect I was going for. We will introduce the Baby 8 as well at some point in time. For now, the output from the little box is just going into the mixer and then the audio out on here. So turn things down and we'll turn the power on. So as we said before, when I was doing it on the we're kind of saturating there. One of the things I said before on the breadboard was that it's almost LFO when it's right down at the bottom, and then as we it is very much a bass synth. Let's have a listen to the triangle output. Now this is going to be much lower output, so I'm going to turn it up quite a bit. But that's a lovely bass. But what I do have, back it off a little bit now, because what I have is this gain control. So as it starts to go up, you can hear the volume is going up quite nicely, but then it's going to get to a point where it starts to overdrive, so we're actually getting a kind of a bit of a distortion on it there. So that's a nice feature that we can incorporate. So what I said as well is, with this in the up position, we've got the CV, but if I flick it down now, should be able to hear. The modulation from the LFO. So that's kind of the basic output. Let's put some CV through it. Back on the square wave. As I said before, we can tune, get some nice effects by tuning the CV and knock some of it out. I'll go really freaky high. But what we can do now, we can get some nice kind of rhythm effects going. So now you're starting to hear what this bass synth is all about. Hey. Okay, but then we can start and process it a little bit more. So what I'm going to do for this next bit is I'm going to set up a patch whereby, bear with me a second, so the way the patch is working now is the output from the 4106 VCO is now going through this voltage controlled amplifier, which is being triggered from a gate out on the Baby 8. It's going through some processing just to get the voltage levels balanced, but it's getting the trigger from the sequencer. With this VCA, it's got an envelope built into it, so you can kind of adjust the envelope directly on the VCA. The output from the VCA is going into an MS-20 style VCF, voltage control filter, and then the output from that is going to go into the mixer. So let's start. So straight away we can hear that, and I've got the VCA involved. We can get a bit more. So that's just altering the type. Bring it back something more percussive. Right, let's sweep the filter. Bring the LFO back in. So there we go. The latest member of the Little Boxes Orchestra, the 4106 VCO, with one or two other little tricks up its sleeve. So I've shown you how I developed this circuit. It's a fairly simple circuit. You've got the circuit diagram, you've got the stripboard layouts, you've got pictures of how I put it all together. What more do you need? Go on, have a go, build your own.